What's up, viewers? This is your empathy-based speaking. So the topic for this video is design and analysis of singly reinforced concrete beam using the provisions of NSCP 2015. So ito yung unang topic natin sa RCD. So lately, napag-alaman natin na sa board exam, ang gagamitin ng provision sa design is NSCP 2015. So, in this video, matutunan nyo kung ano yung mga provisions ng NSCP 2015 at kung paano gamitin. Iko-compare din natin yung dating provisions ng 2010 sa 2015 kung ano yung nabago. So, makikita nyo doon yung procedure. So, makikita nyo dito sa video na to. So, here we go. So, ito yung reinforced concrete beam natin. So, ang component ng beam natin, yung steel, tapos the rest is concrete. So, bakit ba kailangan natin ng steel? Bakit yung steel nilalagay sa baba? So, kung babalikin natin yung lesson natin sa strength of materials, yung flexural stress, ang nagiging deformation is bending. So, bending yung nagagawa ng moment. So, in this bending diagram, so etong ibabaw na portion, ito yung naka-experience ng compression, while ito yung nag-experience ng tension. So, yung steel, nilalagay natin dito sa ilalim na portion kasi yung steel ang magre-resist sa tension. So, yung steel, mataas yung modulus of elasticity niya. So, malakas yung yung resistance sa tension compare sa concrete. Pero yung steel naman, mahina siya sa compression. Pag dating dito sa compression naman, si concrete na yung bahala dyan. That is why tandem sila. So, kung susuriin natin to, at yung area of steel, at yung effective depth natin. So, simula yan dito sa top hanggang dito sa center ng steel. Tapos ito yung base natin. Ito, makikita nyo yung C. Ito yung neutral axis. Bakit neutral axis yung tawag sa kanya? Kasi pag ginawa natin ng strain diagram, yung compression tsaka yung tension, yung effect ng stress gawa ng compression tsaka tension, dito zero strain. Tapos ito yung maximum natin na strain sa compression, 0.03, while andito naman yung strain sa steel. So ito yung tensile stress. So sabi sa NSCP 2015, tension controlled kapag yung strain natin sa steel is greater than or equal to 0.0005. So, yan yung sabi ni NSCP 2015. Now, so kung papansin nyo, ito yung natin, yung 0.85 F prime C. Yan yung compressive stress. Multiplied mo sa area, magiging compression force. So, if you would remember sa strength of materials natin, stress is equal to force over area. So, same din dito sa tension. AS, Fy. So, AS yung area ng steel multiplied by Fy. So, yung FC prime, ito yung stress ng concrete natin, while yung Fy, yan yung stress sa steel, yung tinatawag natin na yield stress. So yung scenario sa design ng sigli reinforced beam tatlo. So pwedeng tension controlled, pwedeng compression controlled, pwede din yung balance design. So sa tatlong to, yung ideal yung tension controlled. Bakit? Isa-isahin natin. Kasi yung tension controlled, ang mag-yield dyan yung steel. So ano bang ibig sabihin kapag nag-yield yung steel? So ibig sabihin, kapag nag-yield yung steel yung unang mag-fail. So kung nasa building ka, tapos tension control yung design, nauna mag-fail yung steel, may time ka pa para lumabas ng building or mag-evacuate. Kapag compression controlled, yung steel hindi nag-yield. So kapag yung steel hindi mag-yield, ang mangyayari dyan, yung failure is rupture failure. So bigla na lang yan puputok yung konkreto. So wala kang time para mag-evacuate kung nasa loob ka ng building na yan. So delikado yon. Same as balance design. Kapag balance design naman, sabay mag-fail yung konkreto tsaka yung bakal. So kapag mag-design tayo, we design tension controlled design, or meaning to say under reinforce. So ibig sabihin pala, hindi porket maraming bakal safe ka na. So yung notion ng karamihan na kapag maraming bakal safe, hindi totoo yun. So dapat yung bakal mo hindi siya bababa sa minimum, hindi din lalampas sa maximum. So tension controlled yung rho natin. Okay, so rho yung steel ratio. So must be less than maximum steel ratio pero greater than minimum steel ratio. Okay, so tignan pa natin yung ibang mga formula. So ito. So we have here depth of the compression stress block. A is equal to ASFY over 0.85 F prime CB. Tapos A is equal to rho BD. So saan galing to? So ito, C is equal to 0.85 F prime C AB. Inequate mo yung C sa T. Tapos nakuha mo to. Okay, so we also have here tension reinforcement index given by omega rho times Fy over Fc prime. So kapag may design tayo ng moment for beam reinforced for tension, ito yung natin yung ultimate moment equals to the strength reduction factor multiplied by F prime C times the tension reinforcement index multiplied by BD squared times 1 minus 0.59 omega. So ito yung Rn natin, coefficient of resistance, mu over phi BD squared. So yung natin yung phi or tinatawag na strength reduction factor. So ito yung updated niya sa NSCP. So sa table 421.2.2, so gawan na natin yung diagram. So ang minimum minimum niya is 0.65. So if you have your strain dito, compression controlled yan. Then for spirals, ito minimum niya 0.75, tapos maximum niya is ito 0.9. So kapag nandito siya sa labas nito ng strain ng steel na 0.005 pataas, so dito tension control. While kapag in between, andito yung tensile strain, so ito yung tinatawag natin na transition. So yung formula updated natin based on NSCP 2015. So we have here the reduction factor equals 0.65 plus 0.25 multiplied by the tensile strain minus ito, so compression controlled strain divided by 0.05. So yung strain and tension controlled minus ito yung compression controlled na strain. So yan yung formula natin. So minimum na natin yung 0.65. So again, mabalik tayo dito. Nominal moment. So nominal moment, kapag wala pang stress reduction factor. So that is ASFY times D minus A over 2. Kasi kapag nag-moment ka dito sa C, so eto na yan, nag-moment ka sa C, eto yung tension multiplied by the moment arm, D minus A over 2. Ultimate moment capacity, multiply mo lang siya, so phi mn, yan na. So pwede ka din mag-moment dito sa tension, gagamitin mo naman yung compression, 0.85 F prime C AB multiplied by the moment arm. So eto, dito na tayo sa balance steel ratio for beams reinforced for tension only. So ito yung raw balance, 0.85 F prime C beta times 600 over Fy multiplied by the quantity of 600 plus Fy. So ito pa rin yung formula. So steps in descent of rectangular beam reinforced for tension. So ito yung MU. So ito, bago na ito ngayon. So sa NSCP 2015, okay, so sa NSCP 2015, so hindi yan MU actually, that is factored load WU equals 1.2 DL, yung dead load, plus 1.6 LL. While yung MU, kung sa simply supported, so ito MU sa simply supported, so yung MU natin equals WU L squared over 8. Tapos meron din tayong mga values nito, ultimate moment, depende dun sa sa kung ilang span ng beams. So meron din tayo niyan sa NSCP natin. So sa mga susunod na videos, yun naman tatalakayan natin. Now, so step to compute the balance steel ratio. So using the formula. So you will notice here the beta factor. So, ito yung lumang beta factor. So, 0.85 for f prime c greater than 30 MPa. Then, we also have 0.85 minus 0.5 f prime c minus 30 over 7, but not less than 0.65. So, bago na ito pagdating sa NSCP 2015. So, yung beta factor natin, sa NSCP 2015, so 0.85 when f prime c or fc prime is greater than or equal sa 28 megapascal, less than or equal, but greater than or equal sa 17 megapascal. So 17 megapascal yung minimum. So ito yung 0.85. Now, gagamit naman tayo nung 0.85 minus 0.05 times f c prime minus 28 over 7. Kapag yung f prime c greater than 28 but less than 55 MPa. But when your f prime c is greater than or equal sa 55 MPa, yung gagamitin natin na beta factor is 0.65. So, ito yung tatlong instances or tatlong situation natin sa beta factor. We have A, B, and C. So, ito yung compare natin dito sa old NSCP natin. So, 30. Ay, dito 28 na lang. So, next step sa pag-design, compute the maximum steel ratio. So, yung raw maximum is 75% ng raw balance. Then, i-assume natin na yung raw natin, yung steel ratio is 0.5 ng maximum raw. Now, compute natin yung dimensional reinforcement index. We have omega rho Fi over Fc prime. Then, compute for B D squared. So, eto na. Using the formula kanina sa MU. So, makuha natin yung B D squared. Then, we try values of B. So, eto kapag wala pa tayong B and D. So, try values B of B, roughly assuming D is equal to B. Then, we solve for the steel area. Tapos, mag-try tayo ng bar diameter using the number of bars. So, pi over 4 times diameter squared times n equals AS. Now, we check for the actual steel ratio. So, dapat yung rho natin greater than minimum rho and less than maximum. Kasi kapag bumaba tayo, kulang tayo. So, mag-fail. Kapag lumampas naman tayo, over-reinforce tayo. So, dapat dito lang. So, eto hindi na bago ito sa minimum. Sa NSCP, minimum is 1.4 over Fy. So, meron pang isa yan. Okay, so, minimum area shall be greater than 1.4 over Fy, o kaya naman yung 0.25 square root of f prime c over fy. Now we check for its ultimate moment capacity T equals C. So ASFY is equal 0.85 f prime c AB. Makuha natin yung A. Then ultimate moment. Now case 1, if Fs equals Fy, so if still is in tension, so still in tension will yield under reinforce. So ito yung condition natin. So equate natin yung T tsaka C. Yung A is equal to beta times D. So i-check natin yan. So ratio and proportion 0.03. So strain is to C equals yung strain ng steel is to D minus C. So D minus C. Ito. So when the strain of steel is greater than strain of Y, so sa minimum yan. So Fy over ES, so steel yields. Kapag mas malaki, hindi siya mag-yield. Case number 2. So, before case number 2, so kunin natin yung safe existing ultimate moment capacity. So, nominal moment and ultimate moment. Tapos yung actual. Pero, dapat greater than minimum but less than the maximum. So, mag-check tayo dito using raw maximum. Next, Fs is not equal to Fy if still in tension does not yield. So, ito yung over-reinforced. So, yung raw natin mas malaki sa maximum steel ratio, mas malaki rin sa minimum. So, assume first Fs equals Fy. So, ito, i-discuss naman natin ito sa susunod na video. So, bago ito, mag-ano muna tayo, example muna tayo nung nag-yield yung steel. So, for now, hanggang dito muna tayo. And, abangan nyo yung masusunod na videos natin hanggang sa maubos natin lahat sa concrete design.